Hello, everyone. Today, we look into the remarkable journey of the Kaveri engine, a project that embodies India's unwavering commitment to achieving self-reliance in one of the most complex and strategically vital defense technologies, advanced jet propulsion. This is a story spanning nearly 4 decades, marked by ambitious goals, formidable challenges, and a resilient spirit of innovation that continues to shape India's aerospace future. The Kaveri engine program began in the mid-1980, a bold step for India into the highly specialized field of jet engine design and manufacturing. In 1986, the Defense Research and Development Organization, DRDO, formally tasked its Gas Turbine Research Establishment, GTRE, in Bangalore with developing an indigenous power plant for the Light Combat Aircraft, LCA, Tejas. This was more than just about powering a single aircraft. The Cabinet Committee on Security, CCS, sanctioned the project in April 1989 with a dual mandate: to meet the specific needs of the LCA and, crucially, to establish a full-fledged indigenous base for designing and developing any advanced technology engine for future military aviation programs. The initial target was ambitious: a completion by December 1996 with an allocated budget of 382.81 crore rupees. Early progress saw the Kabini core engine, a foundational component, achieve its first run in March 1995, followed by ground testing of the first full Kaveri prototype in 1996. By 1998, 5 prototypes were undergoing evaluation, with flight trials initially planned for 1999. The Kaveri, initially designated GTX-35 Versus, was conceived as a low-bypass twin-spool turbofan engine designed to deliver approximately 80 kN of thrust, incorporating features like flat-rated characteristics and a twin-lane full-authority digital engine control (FADEC) system. Despite initial promise, India's Kaveri engine program faced significant setbacks, leading to its eventual delinking from the Tejas LCA project. Post-1998 nuclear sanctions severely restricted access to crucial foreign technologies. More critically, the engine consistently battled technical deficiencies. It was overweight, 1,180 kilograms versus 1,100 kilograms target, and significantly underthrusted, delivering only 70 to 75 kN against an 81 kN goal and the IAF's desired 90 to 95 kN. Major hurdles arose from the lack of indigenous material science and manufacturing capabilities, particularly for critical components like single crystal blades. This necessitated reliance on imports and foreign technical assistance. Infrastructural gaps, including insufficient high-altitude testing facilities and the absence of a 50,000-ton forge press, further hampered progress. These technical and infrastructural issues were compounded by systemic and human capital deficiencies, such as a shortage of experienced engineers, a poor work culture, uncompetitive salaries, and inadequate funding. By September 2008, the Kaveri engine was officially delinked from the Tejas, which adopted American GF404 engines. The program had by 2016 incurred nearly 3,000 crore rupees in expenditure. The Kaveri engine program has strategically transformed into a vital test bed for future applications, salvaging investments, and nurturing expertise. As of mid-2025, the Kaveri engine is undergoing advanced flight testing in Russia, with limited series production planned for strategic applications post-completion. A key diversification is the Kaveri Derivative Engine, KDE, a drive variant designed for India's DRDO Ghatak Stealth UCAV. The KDE aims for 46 to 52 kN dry thrust, having shown stable performance in ground tests and simulations. The 13-ton Ghatak, intended for precision strikes, ISR, and air-to-air combat, is expected to roll out by 2026, with KDE in-flight trials on an Il-76 in Russia by late 2025. This project highlights significant Indian private sector involvement, particularly Godrej Aerospace. Furthermore, the Kaveri Marine Gas Turbine, KMGT, a marine variant, has been successfully tested for naval platforms, producing 12 megawatts. Supporting these advancements, GTRE 130 kN engine test facility in Rajanukunte is nearing completion, set to be operational by October 2025. This domestic facility will significantly accelerate future engine development and certification. Kaveri 2.0, India's next-gen jet engine ambition. India's Kaveri 2.0 program, encompassing K9 and K10 engines, targets significantly enhanced thrust and efficiency for indigenous fighter jets. This next-generation engine aims for 55 to 58 kN dry thrust, 90 to 100 kN with afterburner, and an eventual goal of 110 kN with 75 kN dry, striving to surpass US-made F404 and F414 engines. Kaveri 2.0 incorporates advanced materials like single-crystal turbine blades, nickel-based superalloys, and ceramic matrix composites for improved durability and performance under extreme conditions alongside flat-rated performance and FADEC integration. The new core engine is slated for a 2029 rollout, with a full demonstrator by the early 2030s and operational readiness for Tejas fleet upgrades by the mid to late 2030s. While the Kaveri was initially delinked from Tejas, Kaveri 2.0 aims to power future Tejas variants. For the AMCA MKII, requiring 110 to 130 kN thrust, India seeks co-development with foreign partners, example, Rolls-Royce, Safran, emphasizing 100% IPR and comprehensive technology transfer. The Kaveri program's technological advancements are also expected to benefit future stealth bombers and missile technology. India's indigenous development of jet engines, particularly through the Kaveri program, is crucial for its national security, economic independence, and global standing. Historically reliant on foreign defense suppliers, especially Russia, developing domestic jet engines secures India's supply chain, safeguarding it from geopolitical risks and sanctions. Mastering this complex technology would place India among an elite group of nations, including the US, UK, Russia, France, and China with this advanced capability. This not only boosts India's global prestige, but also opens doors for defense exports. Self-reliance in jet engine technology enhances India's strategic autonomy, allowing it to project power without external constraints and design aircraft tailored to its specific needs. The Kaveri program aligns with the Make in India initiative, fostering domestic manufacturing and public-private partnerships. Despite a lengthy development period marked by technical hurdles, the program has demonstrated resilience. The strategic shift to power platforms like the Ghatak UCAV with a Kaveri derivative engine and the ongoing development of Kaveri 2.0 reflect a pragmatic strategy to leverage accumulated R&D and achieve operational relevance. The Kaveri engine, in its various forms, is set to usher in a new era of indigenous propulsion for India's armed forces, solidifying its position in aerospace technology and reinforcing its strategic autonomy. Thanks for watching. Don't forget to like, share, comments, and subscribe for more incredible tech videos.